Alright guys, take a look at A there. We are multiplying f of x and g of x. We take them quite literally as they are, and we add those exponents. Then for C, we have the domain of f of x can be anything. It's just 6 times x, so I can put any x in there and it'll work. For g of x, we have that fractional exponent. Remember that you cannot have negative numbers in that fractional exponent when it's a positive. You guys remember, if you tried to take a negative to the 3/4 power, it wouldn't work out. Must be a positive. So that means that since one of them is all real numbers, but one of them has a restriction, it's got to be non-negative. When you take f times g, that's going to be non-negative. It follows the restriction. Then, when you divide f and g, it's kind of the same deal, only if you got a 0 on the bottom, it definitely wouldn't work. So we would say positive real numbers. Okay, so now we're going to be talking about the composition of functions. That's when I actually take one function and I put it inside another. This is a really important topic in Algebra 2, so I suggest giving a few examples to try on your own this evening. And writing down any questions, of course. When you compose two functions, and you'll really see what I'm talking about in the next example, the domain of the new set of functions, which is made up of both of the original, has x values that have to work in both f of x and g of x. This example is in your textbook. You guys can go ahead and read it over, but again, focus on those examples. Just make sure you understand that the domain has to work for both g and f. Okay, so we are given f of x is 2x minus 7. G of x is x squared plus 4. I want to find g of f of 3. Notice how every time I put a parenthesis I'm saying of. Just kind of a math definition thingy there. Okay, so what this function is telling me, I'm going to ignore the fact that there's g on the outside. I'm going to focus in on my f rule of 3. Okay? I'm going to find f of 3 first. So I'm going to take that 3 and I'm going to put it into f of x. I'm going to say f of 3, I'm going to go to the f function and figure this out. 2 times 3 minus 7. That gives me 6 minus 7, which is negative 1. So I just found that f of 3 is equal to negative 1. Now that I know that, instead of f of 3 in the middle, excuse me, I can change f of 3 to negative 1. So now I have g of negative 1 because I just found that f of 3 is negative 1, so I can substitute it. Now all I have to do is take negative 1 and put it in for x in my g function here. So negative 1 squared plus 4. You get 1 plus 4, which gives you 5. That is your answer, and that's D. Okay, now what we're going to do is we're going to make it a little more complex. We might not have a value to plug in for x. We might have an entire function. So look at part A here. Part A says I want to find f of g of x. My two functions, f of x is 4x to the negative 1, g of x, 5x minus 2. So what this one wants me to do is we're going to use the same idea as before. It wants me to find f of g of x. And again, I'm going to focus on the middle. G of x is 5x minus 2. I don't have a value for it, but it's totally fine. What I'm going to do to help this make sense is I'm going to replace g of x with the actual function. 5x minus 2. Now what this is telling me to do is go to my f function, and wherever there's an x, I'm going to put this expression instead of x. So I'm going to go back to my f function and say 4. Now here's where the x is, so here's where I'm going to substitute in my expression. 5x minus 2 to the negative 1. Now I'm not going to distribute, okay? And we might have done this in the beginning to make this a lot easier. But I'm going to say this entire expression is being raised to the negative 1 power, so the entire thing is going to move to the bottom. So we're going to change this to 4 over 5x minus 2. That would be my function. That's my new function. You guys give B and C a try. I'll put the work on the board, and then we'll talk about the domain. Okay, now go ahead and check your work with what you might have done, or just take a look and write down what I have as good steps. To find g of f of x, what I did is I focused on the inner part here. F of x is the same as 4 times x to the negative 1. So I replaced f of x with the actual function. Then I put that function into g of x. It really helps to write this step out. Seriously, show your work. You can't go wrong. Then we plug it in and we simplify. Notice what I did here. To simplify this, I had to distribute my 5 to that function. That's one term, so I just distributed to the 4 there. I get 20x to the negative 1 minus 2. X to the negative 1 has a negative exponent. 20 is fine, that can stay there, so x to the negative 1 moves to the bottom. Let's talk about the domain. The domain of this function, remember we said that's all the values x can be. That domain has to work for both of these functions. G of x is fine. X can be any number here. But look over here. I have a negative exponent. If I move that to the bottom, my function would look like this. It would look like 4 over x. And we know by now we cannot have a 0 in the denominator. So for this function, the domain is all values of x except for 0. So since f of x has a restriction, since f of x can't be 0, the same thing is going to be true for these functions. X cannot be 0. Look at C now. We're actually replacing f of x with the function. Then we're taking f of x and putting it back into itself. Like that. Here's what I did to simplify. Remember, order of operations, we have to focus on that exponent first. I distributed the exponent to the 4 and to the x to the negative 1. That left me with 4 to the negative 1 times x to the 1. I moved the 4 to the bottom of my expression here, and I was left with just x. Again, the domain, all real numbers except 0.